Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss the drawbacks of delta modulation technique that we have just now discussed. There are two drawbacks. The first one is slope overload error. Let us discuss what exactly is slope overload error. To understand this, we will take one modulating signal and see how its output will be generated in delta modulation system. So let's say my modulating signal is suddenly increasing with very high rate of change. That means it is increasing at very high rate from one value to some another value. Slope overload error will take place in such kind of situations where signal is increasing or decreasing at very large rate of change. Now in such a case, let us see how the another signal mcap t will be generated. If I start from the reference value of 0, after every one sampling time period, you can see because mcap t is less than m of t. So this is my m of t, my original modulating signal. And now let us draw mcap t. Let me use some different colors. So if this is your original reference value of mcap t, for after the first sampling time period or after first clock cycle, we can say that mcap t will increase by certain step size. This step size by which mcap t increases is constant. It is as per the specifications of digital to analog converter, but it will be always constant. So every time the counter will count in upward direction or downward direction, the digital to analog converter will increment or decrement by a fixed step size. So now you can see mcap t is still less than m of t. So in the next clock period, again the counter will increment its count, but DSC will increment the value again by a fixed step size. You can see this will keep on happening after every clock period, and as you can easily make out that because the increase is by a fixed step size and because your original signal m of t is changing at very high rate of change, the signal mcap t cannot catch up with m of t. Now this will mainly happen, as I told you earlier, when m of t is increasing or decreasing at very high rate. On the receiver side, when receiver receives ones and zeros, it will try to demodulate the signal. It will first generate mcap t, which looks exactly similar to what we have drawn here. And when this mcap t is passed through a low pass filter, the smoother version of mcap t will be very much different from m of t. And because of this, the demodulated signal will not be proper. It will be in its distorted form. This is called slope overload error because it mainly occurs when the slope of m of t is very large in its magnitude. Positive slope means m of t is increasing, negative slope means m of t is decreasing. Slope overload will take place in both the cases. So the main problem that slope overload takes place is the rate of change at which mcap t is increasing is very small compared to the rate of change at which m of t is increasing. To avoid slope overload error or slope overload distortion, I repeat, the two important factors are the rate at which m of t is changing. To find out the rate of change of any continuous time signal, we take its derivative. So dmt by dt is the rate at which analog signal is changing. The rate at which mcap t will change, because mcap t is a staircase like signal, its rate of change can be easily calculated. This much is the change in the amplitude, which will be equal to one step size, let me call it delta, and this much is the time period in which the change of delta takes place. This is equal to one sampling time period ts. So the rate of change of mcap t will be nothing but delta upon ts, the change by delta in time period ts. The slope overload takes place because dmt by dt is greater than delta by ts, which is rate of change of mcap t, and hence to avoid slope overload, dmt by dt has to be less than equal to delta upon ts, which is rate of change of mcap t. Now it may happen that the rate of change of m of t is not a constant value and it is changing in different regions of m of t. In that case, we should consider the worst case scenario, and we should say that the maximum value of dmt by dt should be less than equal to delta upon ts. I repeat, delta is the step size and ts is the sampling time period. So this condition will avoid the slope overload error.